And so now this is another 2-port shunt through measurement. This time we're using DC blocks because it's a 5-volt DC voltage and we don't want to damage the front end of the scope, so we put DC blocks here. And we're measuring through a 2-port probe, which is a really convenient way to make the contact. This is our new P2102 probe, and so it's a 4-point contact, which is much better than the P2101 probe. This will allow us to measure much lower in impedance than we could before. It's also a browser probe, so you can hand hold it, but I have it on a holder just so that my hands are free. And we'll go ahead and we'll run that. And so here you can see this VRM is just about 10 milliohms, and it's relatively flat. Let me move this out of the way. Okay, occasionally you can see the output voltage ripple that shows up in the screen, and that's just at about 1 millivolt per division, so it's a really small signal. We're using spectrum view here so that the spectrum view can measure really tiny signals really well, and that's how we're able to get this clean plot. Here, this dip, that's from the ESR of the ceramic capacitors. That's the resonant dip, and we don't have all that many data points, so that's why that looks a little bit flat there. And now we hit the ESL of the ceramic decoupling caps, and so now it's going to increase in a inductive fashion, so about plus 6 dB per octave. That makes it pretty easy to measure 2-port shunt through impedance of your VRMs.